Let me begin by saying that I'm enormously grateful for the enormous hospitality that my wife and I have received here. It was an unforgettable experience at every level. The award really recognizes the effort of the people who have worked with me for the last 41 years, students, postdocs, etc. And so the credit is all theirs. And so on behalf of the entire group, I accepted the award. And it basically reflects how one can, by surrounding yourself with the best people around, you can really achieve some significant advances in scientific fields. So actually that's a field that we have not worked in quite some time. However, molecular electronics refers to doing electronic circuits that are mediated by a single molecule, which is really an amazing achievement. So imagine you have a molecule, you make a contact at both ends, pass a current and measure the properties. That's molecular electronics. And we're one of the first to do that. This was a while back, but we actually got the cover of Nature on the single molecule transistor many years ago. Batteries typically have a high energy density, meaning you can store a lot of charge. That means that your vehicle can go, let's say, 400 kilometers. But they cannot do fast charge, meaning acceleration. And so in a battery car, you step, and it slowly goes to speed. But you really want to combine high charge and discharge and high energy density. And so these materials that we develop, these are based on organic molecules. They have the capacity of batteries, but the charge-discharge of a capacitor that can charge or discharge very fast. For example, the battery in your cell phone takes a couple of hours to charge. The batteries we develop could be charged in less than a minute. And so you combine both. That's a tough problem. So in terms of electrochemistry, fortunately, is involved in many energy-related fields. So for example, making hydrogen through electrolysis is an electrochemical process. Batteries are electrochemical processes. Fuel cells are electrochemical processes. There's now a lot of interest in using electrochemistry to derive chemical transformations. So for example, doing synthesis basically with electrons, which is electrochemistry, that has the potential of providing very efficient processes, and in addition use it as a means of, let's say, generating hydrogen at low cost. You can store that hydrogen, serves as an energy storage device similar to a battery, except that it can store a lot more energy. And so the idea of using electrochemistry in all of these various fields, I think, is where the challenges remain. Doing this in devices that use abundant elements, so abundant metals, that are long-lasting, and that have high performance. I think the problems that we're addressing, so the energy challenge, right, broadly defined. So this is the global energy price. We have the global energy challenge. And so I think it provides an opportunity for nations to put aside their differences and look at what they can do together. And I think meetings like this provide a forum to meet other people with similar ideas or maybe different ideas of how to approach the problems. And I think the scientific community should take advantage of these opportunities to forge new links to address this, what is ostensibly the challenge of our lifetime.